what we find with these real-life max-min problems that we're going to work with is that the start, it's really important to draw a diagram. Draw some sort of picture that represents what you're working with. In this example, we're doing a piece of carry-on luggage. So we can draw, I can draw my suitcase. Whoa, that's awful. Okay. There we go. There's my suitcase. Beautiful looking suitcase.
Where'd you get it?
Sears, because they're closing down, so everything's on good sale.
See why it's
Okay.
on a cheap.
Yeah. So there is our suitcase, and it says several models of carry-on luggage have a length 10 centimeters greater than depth. The depth, the width, and the length can't go over 100. So the hardest part in these questions is deciding on what am I going to make my variable, and how is everything else related to that variable. So I'm actually going to use this line right here. Several models have a length 10 centimeters greater than their depth. So the length is being compared to the depth. So I'm going to make my depth x, and then I would know that my length is x plus 10. How do I figure out what my width is? And I have to do it in terms of x. Do you see that all three of them have to add up to 100? So your width plus your length plus your depth have to add up to 100. So if this one was 20 and this one was 30, it'd be super easy for you to figure out that that was 50. Because you just add up these two and then subtract it from 100 to find out what's left. Well, algebraically, we can do that as well. If I want to figure out my width, it's going to be 100 minus my length minus my depth will equal my width. So if I plug these things in, if I minus my length, that's x plus 10. Notice how I put that in brackets because you'd subtract the x and you'd subtract the 10. And we'll also subtract our depth, which is another x. Simplifying this, we get that our length is 90 minus 2x. We just completed the hard part of any of these word problems, is figuring out from the information how to label things. Now we get to the easy part, which is just our regular math. Which still is not necessarily that easy, but we want to find a maximum volume. So we volume equals, multiply them all together, and then use our skills with what we know about polynomial functions to get a sketch of this graph and then be able to put it into our calculator. So I've got length times width times height for my volume. If I was going to sketch this graph, and being able to sketch it without your calculator is important because that's how you can set up your window. I know that one x-intercept is at 0. Where's another x-intercept? Negative 10. And the last one? 45. What kind of graph is this? X squared, x cubed, x to the 4, x to the 5? It's cubed. And will it be a positive x cubed or a negative x cubed graph? It's a negative x cubed graph. Because if you take your x, multiply by negative 2x, multiply by x, you will get a negative 2x cubed. So it will act like a negative x cubed graph whose end behavior acts like a line with a negative slope. Through each of those, will they bounce, bend, or go straight through? Go straight through. So it's going to start up here, go straight through, go straight through, go straight through. And this gives us an idea of its shape. As far as our situation, not all of this makes sense. We can't have negative x values. You can't have a suitcase with a negative height. If you go past 45, if this is 50, that makes this 60. You're already over 100. And so that what you would in order for it to work, you'd have to have a minus 10, and that doesn't make sense. And so our only part that makes sense are these values in between 0 and 45. So now that we have the idea of what we're looking for, and we're looking for that maximum,